Okay, hello everybody. I'm gonna go over what a calorimeter is and also do example one in the notes. So right below here, this is a calorimeter. And I would pause the notes if I were you and do a quick sketch of that so that you can follow along and take some decent notes on what a calorimeter actually is. So what a calorimeter is it's kind of like a styrofoam cup that you get your coffee in. It's well insulated so heat isn't lost to the surroundings. You know, you have the styrofoam cup on purpose so that it keeps the heat within the coffee. So it's the same deal here, kind of like a huge cooler if you want to think of it like that as well. And this calorimeter is made up of or is filled with water. So that plays an important role because we know the different variables for water. All right, so here is the water. So in the water, we measure water in volume in milliliters, and a milliliter always equals a gram. So that's important because it's going to help us with the mass. Up here we have a thermometer, and so the thermometer is sticking in the water. So it's giving you the delta T for water, which is T final minus T initial. And then we also know the specific heat for water, which we just have to have memorized, equals 4.18 joules per gram degrees Celsius. So what I was doing just there was gathering my units to solve for the energy of water. Energy of water equals Q equals MC delta T. So if we look at our different things, we've got a delta T we could solve for, we got a specific heat we could solve for, and we have a grams that we solve for. Okay, so what this allows us to do is the Q of water will equal the enthalpy of a reaction. So inside this vessel right here, we have a reaction that takes place. Okay, so if the reaction is exothermic, giving off energy, then the Q of water is going to be gaining that energy. So a positive Q of H2O will give you a negative enthalpy from the reaction. So we could look at this in a different way as well. We could look at this here, and we could pretend like we got our enthalpy in the reaction is endothermic. Okay, so in that case, the Q of water is going to be um, exothermic. So in this scenario, you got a negative Q equals a positive enthalpy. So what you do first is you always solve for the Q of water, and then you'll have your enthalpy because it'll be the opposite sign of it. So the strategy is always solve for your Q of water first. All right, so we're gonna go down and we're gonna solve this problem below here. This example number 1. Okay, so in here, here's our example right here. Here's example 1. It says you have 16.9 grams of the sodium hydroxide. You got 70 grams of water. So let's start labeling things. So of our water right here, we have 70 grams. I could have wrote 70 milliliters. It would have been the same. You guys got to just remember that once again, a milliliter always equals a gram. Let's find some more variables here. So it says the temperature of the water rises from 22.4 to 86.6 grams. So that came from the thermometer right here. So our delta T for water is equal to our T final minus our T initial. So that's equal to our 86.6 degrees Celsius minus the 22.4 degrees Celsius. And we get an answer of 64.2, I believe. Okay. And let's see, what else do we have down here? It says calculate for the delta H of this reaction right here. Okay, so I'm going to go and I'm going to solve for my Q of my water first, because I know in the end that it's going to be equal to my enthalpy, just with the opposite sign. So my Q of my water equals MC delta T. So I got my delta T right here. I got my mass right here. All I'm missing is my specific heat, and you guys got to just remember that specific heat for water is always equal to 4.18 joules per gram degrees Celsius. So now we have our specific heat too. So voila, so we just plug everything in. So let's do that. So our Q of water equals our mass, 70 grams, times my specific heat, 4.18 joules per grams degrees Celsius, times my delta T, which is 64.2 degrees Celsius. All right, so let's just look at the units crossing out. We got grams crossing out, Celsius crossing out, and we're left with joules. So we get an answer of 18784 18784.9 joules. That's the Q of my water. So if I want to find my enthalpy, it's the opposite of that. So my enthalpy turns out to be negative 18784.9 joules. My reaction was exothermic. So my delta H within here was exothermic. And the water was endothermic. So this is the final answer to the question, example number 1 provided.